Assalamualaikum and very good morning. My name is Muhammad Azalan bin Mahmud, and the title for my FYP video presentation is Power Distribution with an Environmentally Optimized Dispatch Strategy. This project addresses the environmental concerns tied to the thermal power plants. Tied to the thermal power plants. The main objective is to develop a penalty-based strategy power dispatch strategy that reduce emissions such as carbon dioxide and sulfur dioxide while still meeting the electricity demand efficiently. The approach uh, involves simulation and modeling with a strong emphasis on the data analysis such as using Python demand as the main tool. So I'm using Python here. The main tool I use for this project is Python, specifically leveraging its libraries like NumPy, Pandas, and Matplot library, alongside the optimization techniques such as sequential least squares programming (SQP). Python is well suited for this project due to its higher flexibility in handling large datasets, strong support for numerical modeling and optimization, cost effectiveness, open source, and ease of integration with environmental engineering models. Python also allow me to simulate 24-hour power generation scenarios using under the different analyze emission outcome with different condition with and without solar and with penalty cost applied to pollutants. So let me demands. So using this is the Python, and then the let me briefly explain out how the simulation works. I model 6 thermal generators. I model 6 thermal generators and 1 solar unit. Each generator was designed to minimize the total cost of emission, factoring in real-world penalties of CO2, SO2, and NOx. Constraints ensure that generation met the hourly demand, respected RAM limits, and stayed within fuel boundaries. The two simulations were run without solar and penalties and with solar and penalty costs. The Python interface calculated optimal dispatch strategy hour by hour, showing how each generator should respond under different environmental regulations. So the result clearly shows about the emission without solar, the power output with solar, emission with solar, and uh, and power output without with solar. So what I learned from this, validated the effectiveness of using both solar energy and penalty strategies to control the emissions. The result aligned with existing literature, which suggests that pricing solution pushes power systems towards cleaner generations. But using this Python, while Python is very powerful, there are some limitations. The model does not account for transmission losses or grid instability. Solar power is modeled simply as an energy source without weather variability. Emission rates and penalty costs are based on us. And then this limitation suggests that while the tool provides insights, real-world implementation will require more robust systems. Conclusion, my conclusion, the tool supported the project by helping model power dispatch efficiently, demonstrate how penalty best strategies can reduce emissions, and proving that combining renewable like solar with traditional power generation is environmentally and economically beneficial. From this project, I learned the value of combining economic models with environmental awareness and the importance of balancing energy demand, system constraints, and sustainability goals. That's all from me. Thank you.